Hello, Mrs. Bennett here again for part 2 of Systems of Inequalities, and this is going to focus on word problems. So inequalities in word problems are also often called constraints, and this is some sort of limitation that's presented in the problem. Now this really relates to real life math because businesses and things like that have a lot of constraints. They have constraints on budget, constraints on time, constraints on materials, etc., etc. Now, this problem that we're doing here is focused on 2 constraints. So it is very basic in terms of what an actual real-world problem would be like. Okay, so constraints can actually be modeled with inequalities, because there's some sort of limitations, which means we either need to have less than that or greater than that. So here's our example. This is a company called What's Up Toys, and What's Up Toys is a small toy company, and they specialize in toy cars and trucks. The people at this company are confident that they can sell all of their toy trucks and cars that they make in the holiday season, but they have 2 constraints that they have to deal with for their production each day. So constraint number 1 is about wheels. So this is a material constraint. So each car needs to have 4 wheels on it. Each truck needs to have 6 wheels on it, but they only have 360 wheels in stock for that day's production. The second constraint is about seats. So each toy car needs 2 seats, each of the toy trucks has 1 seat, and they only have 100 seats available for that day's production. Now this doesn't include labor, employees, money, time, or any bills or anything like that. So you can see that it is very basic in terms of what a business would need to analyze. So we're just doing this to get the general concept of what would happen. Okay, so let's look at our coordinate plane, because they actually tell us what our x stands for and what our y stands for. So let's write that up here. So x represents the number of toy cars that they're going to make, and y represents the number of toy trucks. Okay, so when we read our constraint, we can now write an inequality. So each car needs 4 wheels, so that would be 4 for each x. Each truck needs 6 wheels, so that would be 6 for each y. And I am adding these because we have a total. And since we have only 360 available, that means that they can use less than or equal to 360. So this is our constraint about wheels, and I like to label them. Okay, our next constraint is about seats. I'll put that down here. And you can see that each car needs 2 seats, so that's 2 times x. Each truck needs 1 seat, so that's 1 times y. And I'm adding them because we have a total number of seats, which is limited to 100, so that is less than or equal to 100. Now, once we get these modeled in inequalities, then it's just normal algebra, and we graph and find the intersection points. So we need to get these in slope-intercept form. So subtract 4x from both sides for this one, which will give us 6y is less than or equal to negative 4x, plus 360, and then divide by 6. Now, because these are inequalities, we need to look to see if we need to flip the sign, and in this case we don't, because we are dividing by a positive. So we get y is less than or equal to negative 2/3 x plus 60. And let's go ahead and graph this. So we have a y-intercept of 60 and a slope of negative 2/3, which is down to right 3. However, this counts by tens, And the x-axis count by 10, so I need to go down 20, right 30. Down 20, right 30, down 20, right 30. So you may pause here if you need time to graph this. So we have an equal sign here, which means a solid line. And our shading would actually be below. So I'm just going to put in my little stripes. Sometimes I don't even like to put in the shading until I know where the intersection is, and then I just wait and color that in. Okay, so our second inequality here is for seats. So let's get this one in slope-intercept form. So I'm going to subtract 2x, which means I get y is less than or equal to negative 2x plus 100, and I don't need to divide here. So we have a y-intercept of 100, a slope down 2, right 1, which means on this scale I'm going to count down 20, right 10. I'm going to go all the way across my grid. Okay, there's my intersection point. I'm going to label that. That's 30, 40. I'm going to keep going. This one's also a solid line. And it is also shaded below, which means this way. And you can see my intersection of the shading is this right here. So I actually like to get rid of the rest of this because I don't actually need it because it's not part of the system anymore. So you don't have to erase it all the way, but I like to erase a little bit so that it's not distracting. Okay, so here is my solution set. So anything in here, in the shaded region, I can make for cars. So I could make 20 of each and still be within my restrictions. I can make no cars and 50 trucks and still be within my restrictions. Now you can see this is a quadrilateral. It's got 4 sides. And here, and here. And it has 4 vertices. I'm going to label the 4 vertices. We have 0, 0, 0, 60, the 30, 40, which was the intersection, and then down here at 50, 0. Now, these 4 are the like the maximums or minimums of my restrictions because they're on the very outer edges. Okay, so I'm actually going to use those to find my profit down here. So this says suppose the profit of each toy car sold is $1 and the profit on each toy truck sold is $2. How many cars and trucks would What's Up Toys make in order to maximize the profits? So maximize means get the most profits. So I know that these vertices of this little shaded region here are the most that they can do. So I can do 30 and 40, 0 and 60, 50 and 0, or 0 and 0. Now this guy doesn't make sense. If I make 0 of each car, I'm going to make $0 of profit, which is not going to maximize my profits. But I don't know about the other ones, so I'm actually going to find my profits. So the profit, if I make 0 cars and 60 trucks, would be $1 times 0 plus $2 times 60, which would make a profit of $120. Now, that's just for one day, so that's pretty good. The profit for the 30-40 would be 1 times 30, so $1 for each, plus $2 for this 40 trucks, would be 30 plus 80, that's only 110. So not a max profit, I'm just going to cross that out. And then the last one, profit for 50 cars and no trucks would be 1 times 50 plus 2 times 0 trucks would only give me a profit of $50. Clearly not the maximum. Okay, so the maximum profit happens if I make no cars and 60 trucks. So max profit of $120 if they make no cars and 60 trucks. And that is how you do these problems.